This video is brought to you by Executive Chief and Platinum. Question 1. We are asked to solve for x and we are given an equation. And I hope you can see that we cannot factorize this equation, so we need to use the quadratic formula. Alright, so if we apply the quadratic formula which is given in the formula sheet, just to remind you, this is the quadratic formula minus b Alright, so that's given in the formula sheet. So let's apply the quadratic formula to this equation. Alright, so if you go to your calculator, simplify. Okay, let me start this from scratch. Starting with the plus. To get the first solution for x. Any number multiplied by 1 will still be the number, but just to follow the formula, we'll punch it in like this. And our first possibility for x is, and we were told to round it off to 2 decimal places, so this will be 5,65. Or the second possibility for x, to get that, we will just change the positive to a negative. So our second possibility, 0,35. Right, so let's move on to 1.1.2. Again, we're solving for x. We're given some bases and exponents, and I hope you could see that both 8 and 16 could be written with a base of 2. So 2 to the power of 3 will give you 8. And 2 to the power of 4 will give you 16. Okay, now that both bases are the same, we could just equate the exponent part. So we've got 3 equal to, this is 9x bring the 8 over, take the 6 over, 9 minus 8 is x, and that's 10. That is our solution. 1.1.3, again, we're given an equation to solve. It'd be simple if we take this part of the equation to the right, and then it will become negative, and we bring the 12 to the left. So we have x plus 5 minus 12. To simplify, alright, and of course we can square both sides. You can expand if you need to, and then you can check that. And of course, the square root is cancelled by the square. So that should be x squared. Bring the 5 over. All right, now to factorize this, we need, because you've got a positive there, so we need two numbers that when added will give you 15, but when multiplied will give you 54. I hope you all agree that those numbers will be 9 and 6. 9 plus 6 is 15. 9 times 6 is 54. So then we could factorize. We could simplify to x equals to 9 and x equals to 6. But then remember, if you've got a square root in the original problem, you always need to check your solutions. It's possible that not both solutions will be correct because of that square root. So let's plug both solutions into the original equation. So let's check. Let's start by checking x equals to 9 first. So let's check this solution first. All right, so if we check that solution, so 9 plus 5, 9 minus 5, is it going to give us 12? Let's see. So we've got 9 plus 5, and 9 minus 5 is actually equal to 4, so we've got the square root of 4. Still going. 9 plus 5, square root of 4 is 2. 9 plus 5 is 14, 14 minus. So it turns out that that is the correct solution. And of course, if we plug x equals to 6, it will not give us 12 will not equal to 12. So the solution is x equals to 9. So again, remember, this is very important. If you've got a square root in your question, then you must check your solutions to see which one is the correct one. All right, moving on to 1.1.4. Again, we're solving for x, but we're also given our expression in terms of a, and we're told that a is equal to 889. So we first want to factorize our numerator. We can factorize our numerator into a plus 1, a minus 1. And of course, those two will cancel. And we are left with a plus 1. We're told the value of a is 889. So we're going to add 1 to that. So our final solution for x will be 890. Let's move on to the next question. All right, still solving for x. We're given f of x, and f of x is given by that expression. So we multiply both brackets. And don't forget that minus 6 there at the end. And we're told that f of x should be equal to 0. Then we can simplify further. It's negative x, negative 6 minus 6, negative 12. And then we can factorize. All right. Now we're looking for two numbers subtracted. They give us negative 1. Multiply, they give us negative 12. And I hope you can agree that those numbers are negative 4 and positive 3. Because minus 4 plus 3 will give us negative 1. But negative 4 times 3 will give us negative 12. And we could simplify those brackets into x equals to 4 or x equals to negative 3. All right, moving on to the last question. Here we're told to find the values of x for which the first derivative is bigger or equal to 0. So that means we need to take f of x. We can actually take it from there So if we take this part as f of x, which it is, so if we want to take the first derivative, and the first derivative will be 2x minus 1. And we're told that this must be bigger or equal to 0. Now it's easier to simplify. We could take the negative 1 to the right, divide both sides by 2. So x will be bigger or equal to a half. That is our solution. Thank you.